Hello everyone, welcome to this video. Now let us move on to some other problems related to solenoidal vectors. So we have this question which says that prove that the vector defined by a vector, that is defined to be 3y to the power 4 z square I cap plus 4x cube z square j cap minus 3 x square y square k cap, we are to prove that this vector is solenoidal. So now this is very simple, right? So let us move on to its solution. For the solution, we are to show that the del of this vector, this is equal to 0. We have to prove this thing. So for that, we'll calculate the divergence of this vector. So we have del by del x I cap according to definition, del by del y j cap plus del by del z k cap dot with the vector I. So 3y raised to power 4 z square I cap plus 4x cube z square j cap minus 3x square y square k cap. So when you perform this dot product, you have del by del x of 3y to the power 4 z square plus del by del y of 3x cube z square plus del by del z of minus 3x square y square. So the next step is to perform this partial differentiation. So we will obtain, now here look at this term, there is no term containing x, so its partial differentiation is 0. Again here when you perform the partial differentiation, there is no term containing y, so we have 0 here, and in the third case, because there is no term containing z, so we have 0. So that means here you obtain this quantity, the del of vector A, the divergence of vector A as 0. So that means your given vector is a solenoidal vector. Okay, so let us now move on to our second question. It says that show that vector A, which is defined by 2x square plus 8x y square z I cap plus 3x cube y minus 3xy j cap minus 4y square z square plus 2x cube z k cap. This vector is not solenoidal. Firstly, we are to show that this vector is not solenoidal, but the vector, so we define another vector b, which is nothing but x y z square multiplied by the vector a. So we are to show that this vector is solenoidal. So let's get started here with this question. So for the solution part, what we are to do, firstly we'll calculate the divergence for the vector A. So it would be by applying the definition. So del by del x of this first quantity. So you have 2x square plus 8x y square z. I'm writing here directly. So you have del by del y of this term. So you have 3x cube y minus 3xy. And then you have del by del z of the quantity minus 4y square z square plus 2x cube z. So next thing is to perform this partial differentiation. So you have 4x plus 8x over here, and then you have here 3x cube minus 3x, and then you have minus 8y square z plus 2x cube, right? So what do you obtain from here? As a result, you obtain this is 12x minus 3x, so that means 9x, and then from here you have plus 5x cube, and then you have minus 8y square z. So now this quantity is not equal to 0, therefore the vector A, this is not a solenoidal vector. Now this part is clear. Now let's move on to the vector vector B, which is nothing but, so let me write down what is our v vector, that is x y z square into a vector. So that would be, this is our a vector. So I have to multiply this by x y z square times this whole thing. So you have 2x cube y z square plus 8 times x square y cube z cube, right? This I cap, I'm just multiplying this whole terms with x, y, z square. So next term would be plus 3x to the power 4, y to the power 2, z to the power 2, right? Minus 3x square, y square, z square. This is j cap. And for k cap, we will have this multiplied by x, y, z square. So you have 4x, y cube, z to the power 4 plus 2x to the power 4, y as such, z to the power 3, k cap. So this is your vector B. So that means now here you are to calculate the divergence of this vector B. So when you take the divergence of this vector B, so you will have del by del x of this quantity. So that would be 2x cube y z square plus 8x square y cube z cube, right? Plus del by del y of the quantity 3x to the power 4 y square z square, and then you have minus 3x square y square z square, and then for the third term you have del by del z of minus 4x y cube z to the power 4 minus 2x 4 y z cube. So next, when you perform this partial differentiation here, so let's see what do we obtain. So here when you perform this partial differentiation with respect to x, so you will obtain 6x square y z square, and then you have, and the next quantity is obtained when you perform the partial differentiation of this term with respect to x, so that would be 16x y cube z cube, and then when you perform the partial differentiation of this term with respect to y, so you will obtain 6x to the power 4 y z square, and then minus of 6x square y z square, right? So you can clearly see this term cancels with this one. And next, when you perform the partial differentiation of this term with respect to z, so that would be minus 16xy cube z cube, right? This cancels with this one. And for when you perform the last term, it would be minus 6x to the power 4 y z square. So this quantity cancels with this one. So you see, we obtain the divergence of the vector B as equal to 0. Therefore, your vector B, that is a solenoidal vector quantity. Okay. So next, let us move on to our next question, which is, we have question number 3, which says that show that vector F, that is equal to y square minus z square plus 3yz minus 2xi cap plus 3xz plus 2xy j cap, and for the third quantity we have 3xy minus 27z plus 2z, right, k cap. We are to show this vector is solenoidal in nature. Okay, so for the solution of this question, now this is very simple. So you are to calculate the divergence of this vector f. So that would be del by del x of y square minus z square plus 3xyz minus 2x plus del by del y of this quantity 3xz plus 2xy plus del by del z of the quantity 3xy minus, now this quantity is what? We have this to be equal to okay, so here instead of minus 27z, we have in question as minus 2xz, right? So we'll write it, the corrected term 3xy minus 2xz plus 2z. So this is our divergence of vector f. So next we are to perform this partial differentiation with respect to x, so that would be minus 2. Then with respect to y, it would be plus 2x, right? And then with respect to z, it would be minus 2x plus 2. So you see this quantity cancels with this one and this with this one. So you have finally the vector as 0. So we started with this divergence of vector f and we obtained the vector 0. So therefore we can conclude that our vector f, that is a solenoidal vector. Okay. So next we have question number 4, which says that if vector f and vector g are such that del cross vector f is equal to 0 vector, and note that this is 0 vector because cross of two vectors is always a vector quantity, and moreover we have del cross vector g as equal to 0 vector. This is given to us. Then in this case you are to show that vector f cross with vector g is solenoidal. So for this part, what we can do, we are to show that this quantity is a solenoidal quantity, a solenoidal vector quantity. So for that we'll compute the divergence of the vector f cross the vector g. So we'll obtain the dot product of del operator with the vector f vector cross vector g. So now this quantity is equal to using the identity vector operations on divergences and curl. So we have this property as vector g first dot with cross this curl of vector f, and then we have vector f dot with del operator cross vector g. If you already didn't know this identity, so just wait for few more videos and you'll be able to know from where did we obtain this identity, right? As of now you just assume this, that there is some formula of this kind. Okay, so now this quantity is equal to 0. This is given to us in the question. So accordingly we have vector g dot with vector 0 and minus vector f dot with vector g is 0, right? Now this quantity, whenever you take the dot product of two vectors and out of which one vector is a 0 vector, so obviously you are going to get 0, and here also you are going to get 0. Now these zeros, they are scalar quantities and not vector quantities. Why? Because divergence of two vector quantities, that always results in a scalar quantity. So we have 0 here as the answer. So here also we started with the divergence of vector f cross with vector g, and we obtained as 0 as an answer. So in this case we can call this vector to be the solenoidal vector. Okay, and now let us move on to the last question for this video. So the question here, it says that if vector u, not vector, so if u and v, they are differentiable scalar fields. Now that means they are scalar point functions. Then you are to prove that the gradient of this scalar field u cross with the gradient of this scalar field v, this quantity is a solenoidal. This is solenoidal, right? So let's get started with its solution. So in order to check that whether this is solenoidal or not, you obviously first have to check that whether this is a vector quantity or not. Now you know, obviously if u is some scalar, so you can take its gradient, so this will become a vector quantity. And moreover, in a similar way, you have del of v, this is also a vector quantity. So you have two vector quantities, so you can perform the cross product of these two vector quantities, and their answer, that would again be a vector quantity, right? So this is a vector, and if this is a vector, so we can check the divergence of this particular vector. So in order to check the divergence, we are to check that del dot of this whole quantity, that means gradient of u cross with the gradient of v, is this quantity equal to 0? So we have to check this thing. If yes, then this vector is solenoidal. If not, then this is not solenoidal. Okay, so here we can again apply this formula. Now we have this identity which tell you that the divergence of the curl of two vectors, this quantity is equal to vector g dot with del cross f vector minus vector f dot with del cross g vector. So we'll apply this identity over here. So we will obtain del of vector v dot with del cross del u. Now these all of these, they are vector quantities, minus del of u dot with del cross del v, right? So this is what you have. So now this quantity will give you a zero vector. How? This is nothing but this is the curl of gradient of the vector phi. Phi is a scalar quantity, this is the gradient, and when you perform the cross product, this is curl, and this is always zero. You'll see that in the properties. And moreover, if you are not convinced here, so let me calculate this for you. Suppose you wanted to calculate this del cross del u, right? So that would be I cap, j cap, k cap, the components of this del. Now what is this del operator? If you remember, the del operator, that is nothing but del by del x I cap plus del by del y j cap plus del by del z k cap. So accordingly we have del by del x here, del by del y here, and del by del z here. And what are the components of del by del u? If u vector is defined to be, say, ux I cap plus u y j cap plus u z k cap, so accordingly del of u would be del ux by del x plus del u y by del y plus del uz by del z, right? So when you take the determinant of this quantity, so this would be equal to I cap, so that means you apply this operator onto this, so you have del 2 by del y del z of uz, and then you have minus del by del z del by del y of uy, right? And similarly you have the component for j and for k, so this cancels with this one. So finally you will obtain the zero vector here, right? So you can check this one, so you'll obtain zero vector. Okay, so what do we have here? So it would be del of u vector dot with vector 0. And now you already know, whenever you take the divergence of two vectors, one of which is 0, that results in a scalar quantity which is 0. So we have a scalar 0, so this gives you answer finally as equal to 0. So that means here we started with this quantity del of the gradient cross of gradient of two quantities, so this we obtained as 0. So obviously here the vector del u cross del v, this is solenoidal in nature, right? So I hope you got a pretty clear idea about the solenoidal vector and how to perform some calculations on to this solenoidal vector. Well, that is it for this video. Thank you for watching.